All right, this is the 2010 AMC 10B problem number 6. A circle is centered at O. AB is a diameter, so before we continue, kind of start making the diagram so you can make sense of what they're talking about. So just make a circle. We don't know how big we need it. We'll just go there. There it is. It's circle O. AB is a diameter, so we'll pass that right through the middle like this. And A goes here and B goes there. C is a point on the circle with angle COB equal to 50. So, I don't know, approximately there, I guess. And that would be 50 degrees. What is the degree measure of angle CAB? Well, it's not drawn, so we'll have to draw the C to the A. And this is basically a knowledge check. I mean, you either know it or you don't. I don't know how you would get it if you didn't know it. So hopefully everybody knows this. This would be, if you have a circle and there's a central angle, its measure in degrees is the same as the arc's measure in degrees. And if you have an inscribed angle that hits those same 2 points, it will be this divided by 2, right? So in that case, this is going to be 50, and then this will be 25, which is the answer. See you in the next problem. All right, so continuing on with the 2010 AMC 10B, problem number 7. A triangle has side lengths 10, 10, and 12. Let's just get started and make that real quick. It's going to be isosceles with the base being longer than the sides. So 10, 10, and 12. A rectangle has width 4, so just make a random rectangle, and area equal to the area of the triangle. So 4 and L. Well, let's find the area of the triangle. You can use Heron's or Hero's formula if you want, but it's much faster if you just realize that when you drop the altitude of an isosceles triangle, it cuts the base in half, making this 6 and this 6. And you should know your Pythagorean triples. This is the most famous one of all. 3, 4, 5 times 2 is 6, 8, 10. If you don't know your triples, well, learn them for one. But if you don't, you can just do the Pythagorean theorem and get that that height is 8. Then the area of the triangle is half the base, which is 12, times 8. 6 times 8 is 48. 4 times L must be equal to that because the areas are equal. Therefore, L is 12. What does it ask for now? Always check that after you find something significant. What is the perimeter of this rectangle? Well, perimeter is just, this plus this doubled. So 16 times 2 is going to be 32. On to the next one. All right, and this is the 2010 AMC 10B problem 8. It was also the 12B problem 3. A ticket to a school play costs X dollars, where X is a whole number. A group of 9th graders buys tickets costing a total of $48. So we kind of don't know two things. How many 9th graders and how many tickets? We don't know. And a group of 10th graders buys tickets costing a total of $64. How many values for X are possible? Well, we don't know the number of 9th graders. So let's say the number of 9th graders is N. They buy T tickets, or N tickets, I guess it would be. Each costing X dollars. Where X is a whole number, it says their total cost is 48. We can also say that the 10th graders buying tickets costing a total of 64, so they will buy the number of 10th graders times the number of tickets equals 64. How many values for X are possible? This is where that whole number comes into play. What it means is basically that X needs to be a factor of both this and this, but not necessarily the greatest common factor. It could be any one of them. The fastest approach is probably just to list all factors to be safe. I like to pair them up. 1 with 48, 2 with 24, 3 with 16, 4 with 12, 5 no, 6 yes, goes in 8 times. Same thing for 64, 1 and 64, 2 and 32, 3 does not go in, 4 and 16, 5 no, 6 no, 7 no, 8 yes. So what do we do next? We find the common factors. Here's 1, here's 2, here's 3, here's 4, here's 5, and 48, 24, 8, 6. We already got the 8. So 1, 2, 3, 4, 5, we've got all that there is to get. All right, this is the 2010 AMC 10B problem number 9. It was also the 12B problem number 5. Lucky Larry's teacher asked him to substitute numbers for A, B, C, D, and E in the expression here and evaluate the result. Larry ignored the parentheses, but added and subtracted correctly and obtained the correct result by coincidence. That's why he's lucky. The numbers Larry substituted for A, B, C, and D were 1, 2, 3, and 4. So let's do what Larry did. He's going to do 1 minus 2 minus 3 minus 4 plus E, right? Because he doesn't have parentheses on his. The correct result should have had the same numbers substituted but been in these parentheses. 2 minus 3 minus 4 plus E. Like this. And we just need to figure out what number did Larry substitute for E. So we just got to solve this equation. So 1 minus 2 is negative 1, minus 7 more is negative 8. So negative 8 plus E is going to equal, I start with the inner part, so 3 minus 4 is negative 1 minus E. And rather than rewrite the equation every time, just kind of keep it going. You're now going to have minus negative 1 minus E. So minus a negative 1 is plus 1 plus E. And then that's going to be 2 combined with that. This minus distributing inside. So 2 plus 1 is 3 plus E. And then we still have a 1 minus on this side. So that's going to become negative 2 minus E. And lastly, that is equal to negative 8 plus E. So if I add E to this side, I will get 2E. And if I add 8, I will get 6. And Larry will get 3 for E. All right, and this is the 2010 AMC 10B problem 10. It was also the AMC 12B problem number 7. Shelby drives her scooter at a rate of 30 miles per hour if it is not raining and 20 miles per hour if it is raining. So right away, it's a rate problem and there's distances involved probably, so we should probably use rate times time equals distance. And we already have information. There's rain and no rain. Right? So 30 miles per hour if it is not raining. So that's her rate if there's no rain, and 20 miles per hour if it is. Today she drove in the sun in the morning, meaning no rain, and in the rain in the evening for a total of 16 miles in 40 minutes. How many minutes did she drive in the rain? Well, be careful, these are in terms of miles per hour. And so how many minutes, we have to be careful to adjust for that. So we're going to say that it's T hours that she drove in the rain. And then since she drove for a total of 40 minutes, that's 2/3 of an hour, right? 2/3 of an hour. So we can do 2/3 of an hour minus T for her time that she drove without rain. Yeah, so because we're looking for the T here. Okay, then just distribute across. You're going to get 20T, and you'll get 30 times 2/3 is 20 minus 30T. Then what do we do next? Well, it says a total of 16 miles, and we haven't used that information yet. So we should add up the distances, because the total distance would be 16 miles. So if you add that, you will get 20 minus 10T is equal to 16. And then subtract the 16 to get 4, move the 10T to the other side. I probably could have just subtracted 20, but whatever. 4 over 10, which is equal to 2/5. Again, keep in mind, this is in hours. So we have to turn it into minutes now. So it's just 2/5 of an hour. 1/5 would be 12 minutes, so it must be C, 24 minutes.